History is not predetermined. It is shaped by pivotal discoveries and innovations. Consider a world where electricity was never discovered, altering the course of human development. Without electricity, the modern world as we know it would not exist. Technological advancements, communication, and industry rely heavily on electrical power. Society would remain in a state of permanent shadow, lacking artificial light and power. This hypothetical scenario underscores electricity's fundamental role in shaping contemporary life. Electricity is defined as the flow of electrons, which are subatomic particles. These electrons carry a fundamental negative electrical charge. The directed movement of these charged particles constitutes an electric current. This electric current can be effectively harnessed for various applications. It powers devices, generates light, and facilitates the transmission of information. While electricity is a natural force, its controlled application is a significant human achievement. The earliest observations of static electricity date back to ancient Greece. Thales of Miletus noted that rubbing amber with fur could attract light objects. This phenomenon was documented as an intriguing curiosity. For millennia, the true power and potential of this effect remained unrecognized. These initial observations laid the groundwork for future scientific inquiry. In the 18th century, Benjamin Franklin conducted his famous kite experiment. This experiment aimed to investigate the nature of lightning. Franklin successfully demonstrated that lightning is electrical. This groundbreaking work linked atmospheric phenomena to electricity, advancing scientific understanding. Michael Faraday's 19th-century experiments were crucial in understanding electromagnetism. He investigated the relationship between electricity and magnetism through various setups. Faraday discovered the principle of electromagnetic induction. This principle states that a changing magnetic field can generate an electric current. This groundbreaking discovery laid the foundation for modern electrical engineering. It is fundamental to the operation of electric generators and motors. Thomas Edison developed a practical, long-lasting incandescent light bulb. His invention revolutionized illumination, making electric light widely accessible. This innovation fundamentally altered daily life for mass consumption. It extended productive hours beyond daylight, impacting work and leisure. Nikola Tesla's pioneering work revolutionized electrical power transmission. He developed the alternating current AC system, a significant advancement over direct current DC. AC systems enabled electricity to be transmitted over vast distances with remarkable efficiency. This efficiency was crucial for overcoming the limitations of earlier power distribution methods. The innovation facilitated the establishment of extensive electrical grids. These grids could reliably power entire cities and expansive regions, transforming modern infrastructure. The Industrial Revolution initially relied on steam and water power for its early advancements. Electricity emerged as a significant accelerant, fundamentally transforming industrial processes. Electric motors introduced unprecedented levels of efficiency into manufacturing operations. They also provided enhanced flexibility, allowing for more adaptable production lines. This led to an exponential increase in manufacturing capabilities and overall production output. The advent of power grids marked a pivotal moment in technological advancement and societal development. This new era began with the establishment of centralized power plants, generating electricity on a large scale. Electricity was then distributed through extensive networks of transmission lines, forming the grid. This infrastructure became the fundamental backbone of modern society, enabling widespread electrification. Power grids efficiently delivered essential energy to homes, businesses, and various industries. Without electricity, cities would remain perpetually dim after sunset, lacking modern illumination. Gas lamps and candles would become the primary sources of artificial light in urban environments. These traditional light sources would offer only limited illumination, casting vast areas into shadow. This would fundamentally alter urban nocturnal activity, restricting movement and public gatherings. The absence of widespread electric lighting would also significantly impact public safety and security. Modern urban planning and density are fundamentally reliant on robust electric infrastructure. Without extensive power grids, the sprawling, interconnected metropolis we know today would be impossible. Cities would inherently be much smaller in scale and significantly less dense. Urban growth would face severe constraints due to limitations in alternative energy sources. Electric infrastructure is thus a critical enabler of contemporary urban expansion and population concentration. Without modern electric trains, subways, and trams, urban transportation would be dramatically different. These efficient systems, which move millions, would not exist in cities. Cities would rely heavily on steam-powered vehicles for movement. Horse-drawn carriages would be a primary mode of transport. Human-powered transport would also be prevalent, leading to slower, less efficient movement. Modern hospitals rely heavily on electricity for all aspects of medical care. Diagnostic tools like X-rays and MRI machines are entirely dependent on electrical power. Life support systems, surgical equipment, and medication storage also require electricity. Without electricity, medical care would be rudimentary, significantly reducing life expectancy and public health. Without electricity, industry and manufacturing would revert to pre-electric methods. Factories would rely on complex mechanical systems, water wheels, or steam engines. This shift would necessitate a significant increase in manual labor. Production scale and efficiency would be drastically reduced. Modern automation, as currently understood, would be impossible. Global trade would face severe impediments without modern technological advancements. The absence of refrigeration would eliminate the preservation of perishable goods during long voyages. This would drastically limit the types of products suitable for international transport. Communication would revert to slow, physical dispatches, hindering real-time trade negotiations. International commerce would become significantly more localized due to logistical constraints. The overall dynamism and efficiency of global markets would be substantially reduced. Modern telecommunications, including telephones, radio, television, and the internet, rely entirely on electricity. Electricity powers the infrastructure that enables global communication networks. Without electricity, advanced communication would cease to function. This would revert communication to rudimentary systems, hindering information exchange and isolating communities. Without electricity, the digital age would never have emerged. Computers, from mainframes to personal devices, rely on electrical power. Data processing would remain manual, using mechanical calculators or human computation. This would severely limit scientific advancement and information management capabilities. Food preservation is a constant challenge in maintaining global food supply chains. Refrigeration and freezing, powered by electricity, are critical for modern food systems. Without these technologies, food spoilage would be rampant, leading to significant waste. This would necessitate a return to localized food production and distribution. Traditional methods like salting, smoking, and drying would become essential for survival. Modern military power is profoundly shaped by the availability and application of electricity. Contemporary warfare relies heavily on electrified guidance systems for precision and effectiveness. Advanced communication networks, radar technology, and powered weaponry are also electricity dependent. Without electricity, military capabilities would revert to mechanical and chemical technologies. This fundamental shift would drastically alter global power dynamics and the nature of conflict resolution. Population growth is constrained by the limits of non-electric agriculture and resource management. Sustaining large urban populations relies on efficient food production systems. The absence of modern agricultural methods challenges global population support. Efficient transportation of resources is crucial for densely populated areas. Adequate sanitation systems are also vital for maintaining public health in such regions. In an alternate timeline, steam power could have maintained its dominance for an extended period. This would necessitate the evolution of more sophisticated and efficient steam engine designs. Engineering efforts would focus on maximizing its potential for locomotion. Further development would also enhance stationary power generation capabilities. In a world without electricity, mechanical systems would reach unprecedented levels of sophistication. Inventors and engineers would push the limits of traditional mechanisms like gears and levers. Hydraulics and pneumatics would be extensively developed to power intricate machinery. These complex machines would perform tasks now handled simply by electrical power. Fossil fuels would still be burned, primarily for direct heat and mechanical energy. Coal, wood, and oil would power steam engines and provide light. Without efficient electric conversion, consumption patterns would differ. The environmental impacts of fossil fuel use would also be distinct. A society without electric communication and advanced transportation would foster localized communities. The absence of these technologies would limit the interconnectedness between different regions. Communities would largely become self-sufficient, relying on local resources and production. Interaction between distinct communities would be significantly reduced due to logistical challenges. This isolation would lead to a much slower rate of cultural exchange and diffusion. Technological advancements would also spread at a considerably slower pace across different areas. The stability of our known world is not an inherent or guaranteed state. It is subject to constant change, external forces, and unforeseen events. This inherent fragility implies that current conditions are not permanent. Understanding this impermanence is crucial for adaptation and resilience.